Imagine if a master key was invented that could open every digital lock on Earth. That's the threat future quantum computers pose to our privacy. Post-quantum cryptography, or PQC, is our defense. It's a new type of digital security built with complex math that even those futuristic supercomputers can't crack. Think of it like this. If hackers are building a quantum crowbar to snap our current locks, PQC is the reinforced vault that simply won't budge. This is already happening. Tech giants are using PQC today to protect your messages and banking. It's vital because it prevents hackers from stealing your data now to unlock it later when quantum computers arrive. By upgrading today, we keep our digital lives private for the long term.
Human in the loop is a design pattern where an artificial intelligence pauses for human approval before taking a high-stakes action. Think of it as a supervisor mode. The AI does the heavy lifting of sorting through data, but a person makes the final call on anything risky or important. For example, in medicine, an AI might scan thousands of X-rays to flag potential tumors in seconds, but a human doctor performs the actual diagnosis. This combines machine speed with human judgment and ethics. In real life, this pattern is used in everything from self-driving cars to banking to prevent autonomous mistakes. It ensures that as AI becomes more capable, humans stay in control and remains accountable for the results.
How do we recycle precious metals from our old phones without using toxic chemicals? The answer is deep eutectic solvents. A deep eutectic solvent is a tailored green liquid made by mixing two safe solids, like a common feed additive and a bit of fertilizer. When they meet, their hydrogen bonds pull them together, causing them to magically melt into a liquid at room temperature. They are much safer and cleaner than the harsh, dangerous acids we've used for decades. Think of them like a smart liquid, designed to pick out only the gold or lithium from a heap of shredded electronics. This allows us to recycle batteries and gadgets in a clean, local loop, protecting our environment while recovering the rare materials we need for the future.
Think of standard quantum bits, or qubits, as delicate glass bubbles. The slightest vibration or heat makes them pop and lose their information. This fragility is why early quantum computers were so prone to errors. Logical qubits are the solution. A logical qubit isn't a single piece of hardware. It's a virtual qubit created by grouping many physical qubits together to work as a team. The analogy: it's like a relay race. If one runner trips, the others are there to catch the baton and keep the race on track. In a logical qubit, if one physical qubit makes a mistake, the others detect and fix it instantly. Real-life impact. This technology moves us from noisy prototypes to reliable supercomputers. In the future, logical qubits will allow us to simulate complex chemistry to discover life-saving drugs, design ultra-efficient batteries, and solve massive logistics problems that are impossible for today's computers.
Ever wonder if an online photo is real or if a digital diploma is genuine? That's where digital provenance comes in. Think of it as a digital birth certificate for the internet. It's a technology that tracks the origin and history of a file, proving who created it and whether it's been tampered with. For example, it can embed an invisible cryptographic seal into an AI-generated image to confirm its source. In real life, this technology allows for instant verification of academic degrees and helps stop the spread of deepfakes by labeling synthetic content. As AI-generated work becomes common, digital provenance creates a much-needed trust layer for our digital world.
Have you ever tried to understand a movie from just a single photo? That's what it's like when scientists look at only one part of our biology, like our DNA. Multi-omics integration changes the game by combining every biological layer, from our genetic blueprints to the actual proteins and chemicals working in our cells. Think of it like a high-tech GPS for your health. Instead of just seeing a static map, you get a live 3D view of how your body is functioning in real time. In the real world, this means we can detect multiple cancers early through a single blood draw or even predict why people age in sudden bursts. It's the ultimate tool for personalized medicine, helping doctors treat you based on your body's unique big picture.
Imagine the tiny brains inside your phone, called chips. These contain billions of microscopic switches. The 2-nanometer process node is the latest, most advanced way to build them, packing more power and efficiency into a smaller space than ever before. Think of it like a garden hose. Older chips controlled the water flow from 3 sides, but 2-nanometer technology wraps completely around the hose like a tight sleeve. This prevents power leaks, making the chip much more efficient and powerful. In real life, this means your future devices will be faster while using far less energy. You can expect smartphones with much longer battery life, more advanced AI features in your pocket, and even smarter self-driving cars. It's the invisible technology making our digital world faster, cooler, and more sustainable. For further insights, please subscribe to this channel.